Hey everyone, and welcome to a new video on this channel. This time we're going to take a look at Waypoint, which was released a few days ago by Hashicorp. It's of course not a 1.x release, so it's still early days, but I wanted to play around with it and give you a little bit of a feel about how it works. So basically it provides you with tooling to make building, deploying, and releasing software easier. And actually decoupled from the target platforms. So it doesn't matter if you're deploying to Kubernetes or Nomad, or you're using Google Cloud Run or Azure Container Instances. It doesn't really matter. It supports it all. In this presentation or in this video, we're going to take a look first of all at how to get started. Now, I already installed and configured a couple of things in advance, so you don't really have to work through that because they're fairly simple. To install Waypoint, for instance, you can just go here, you download the Waypoint binary. That's a CLI that you install on your system, and then you can get started. And then with that CLI, you will need to install the server component. Now be aware that when you install the server component using the default command, you will need Docker installed on your local machine, and the Waypoint server will be running as a Docker container. What I did, I deployed to Kubernetes. So I used Waypoint install, and as platform I specified Kubernetes. If you have a correctly configured kubectl client and a Kubernetes cluster that it's pointing to, you will find that as a pod in the list. So if I'm doing kget po here, I'll just make it a little bit wider, you will see that there is a Waypoint server 0. It's a stateful set, and that was automatically deployed by this Waypoint install feature. What also happens is in that case that the Waypoint CLI will point to that server. If you check that out, you will see that if you run Waypoint just like that, so Waypoint, it gives you all kinds of options, and it also has a context option, and you'll see that there's a list of contexts, and I already had a couple of those, for example, on my local machine and so forth. But the current context is basically pointing to this server address in the cloud, 51.138 and so forth, and that's indeed the Waypoint server running on my Kubernetes machine. Now on port 9702, you can get to the UI of that. So you'll see if you go to the IP address exposed by your Kubernetes cluster, by the load balancer probably, on port 9702, you'll find this interface. It's secured by a self-signed certificate. And by the way, when you log in, you'll need to provide a token for that. So with Waypoint token, Waypoint token. You can do Waypoint token new. With the token you get, you paste that into the UI to authenticate, and you'll get authenticated to this system. Of course, it will be empty. There will be no projects. I already created a few projects, a simple one called hello, and then another one, Dapper Demo, it's called here. We'll see in a moment how that works. Now let's get started. Let's first check out a relatively simple project, which is this one in the folder I'm in. If I'm opening up code there, so Visual Studio Code from that location, we can take a peek at the code. Now the code is not important, right? And how the code was generated, it's not important. For those who know about it, they'll see that this is basically an Azure function that was created. An Azure function, just one function called hello, and that function contains some JavaScript, and the JavaScript that we use is the default code that Microsoft provides when you do an HTTP trigger. That's all fine. It's not about the code. What we do get here in an Azure Functions project, where we also said we want to use Docker, so that's with func init, then -- docker. The Azure Function core tools provide us with a Dockerfile already. And that could be the case. It could be the case that you already have a Dockerfile that you want to use to build and then further on deploy and release your software. And Waypoint is perfectly able to work with that. Now, this code that we have here, Azure function or not, doesn't really matter. It is of course Node.js, right? How do we then work with Waypoint and use it to do our build and our deploy? Well, you'll need to create a Waypoint HCL file. You see that here. The HCL file starts with a project and then one or more apps. So you see this app stanza over here. We give the app a name. You can give it some labels, but the fun stuff of course happens here. You define a build phase, and this build phase is a simple one. We say just use Docker. It will then use the Dockerfile that's in the same folder, right? If you don't have a Dockerfile, you can actually ask Waypoint to use buildpacks. We'll see later how that works. But basically, buildpacks will automatically create a Docker image from the code that you are writing. More about that in a moment. Now, because we are deploying to Kubernetes, we'll need to push this to a registry. There's no point to have this in my local Docker images on my local machine. So with the registry option, we can say use Docker Hub. Other registries are supported, and I give the image a name, a tag, and so forth. Now, this does the actual building and pushing based on the Dockerfile. Then we go to the phase which is called deploy. Now, as I said earlier, they support multiple deployment targets. It could be generic Kubernetes. It could also be, for example, Google Cloud Run or Azure Container Instances. Then depending on the target, you will have something else in the use clause over there. In this case, it's just use Kubernetes. And if you look at my code, you will not find any Kubernetes YAML files here. I don't need them because that's what Waypoint is actually taking out of my hands. But of course, Waypoint cannot know everything. It cannot know what port my application is running on. And Waypoint also wants to do an HTTP probe for liveness to my application. I need to specify let's say the probe path over there. So, and by the way, it's optional. You can use a default path, but I just specified it here. So you realize there is some probe path will be needed. And by the way, that can present problems when you have containers that don't have HTTP endpoints, because in that case, I have not found a way to define probes in another way. More about that later. But in this case, because the application is an Azure function, it exposes HTTP endpoints, this will work. No Kubernetes YAML required for me to deploy the app. Of course, deployment is something I can do on a regular basis. Doesn't mean I'm doing an actual release, right? We decouple deploy and release. In this case, I'm also going to release right away afterwards. And the release, I'm going to use a load balancer on Kubernetes to expose my service, my Azure function, on a public IP. Now, what Waypoint is doing, it will give you also interesting URLs as an entry point to your deployments. So you might have a v4, a v2, a v3, and so forth. For each of these versions, if they're running live on the system, you get URLs to actually navigate to that version. Now you'll see in a moment a glimpse of how that works. Now, when you have your HCL file, which is pretty basic and easy, and it's well documented as well on the site, what you have to do is you have to do Waypoint init. So Waypoint init, because if you don't have it, this is the first time you run it, it will need to be created, the project and the app, so it's also visible in the UI, right? So Waypoint init is a requirement. If you would run Waypoint up without init, he will tell you about that. So I run Waypoint init, doing some validations. He says, well, this HCL looks correct. The project is initialized. And that means that, again, if you were to start from scratch, the project would appear here as WP test hello. And within the project, you will then find your application because you define that in the HCL. Okay, that's great. Now, let's see how we can then actually build and deploy our application. What I could do is just run Waypoint, not Waypoint, or I could use a point maybe, but Waypoint up. would do all these steps. It would do a build and push in this case, a deploy and a release. You could also separate this with waypoint build, and then you do waypoint deploy, and then you do waypoint release. When you're using waypoint in like a CI/CD system, and there are some examples provided by Hashicorp, for example, for GitHub Actions and for GitLab and so forth, you could indeed use those separate steps and also use waypoint as your actual real live deployment mechanism, not just as a part of your local development workflow. In this case, I just want to run waypoint up to do all of these steps, right? So if I do that, waypoint up, he first starts with the building. As I said, he builds from the Dockerfile because I said use Docker. There you also see he's injecting the waypoint entry point. That entry point provides us with additional capabilities, like for example, tracking the logs from the application, but also execing into the container to troubleshoot the container. Okay, the push is done already. Now the deployment happens. That's a deployment to Kubernetes. And as I said, I did not specify any YAML files. So he's doing that for me. But of course, he has knowledge of the port 80 and the probe path as well for the liveness probe. So he's waiting for that to become available. And then he says, I'm going to release it. Now you will see that, of course, because I ran this already a few times before I do the video. I do these videos in one take, by the way, but I do prepare the videos. What you'll see now is that you get, first of all, a deployment URL, which is tied to the version. So in this case, we have a v6 because I already did this a couple of times just to test. And I also released the application. This release will point to the v6 version. Now, the other versions are not live anymore on my system because I destroyed them. If I don't destroy them, I would have these versions. I could have these versions running as well side by side. Now, this of course is interesting because this is provided by Waypoint. They provide these Waypoint run URLs automatically also with a certificate in front of it. And if I go to that URL, you will see that this is my Azure Functions container running on my Kubernetes host. Again, the waypoint entry point is making all of this possible. And by the way, if you don't want to have this, you can of course remove the waypoint entry point. You don't have to inject it into your container. But it makes going to your different versions from anywhere basically a little bit easier. And of course, if I'm checking out my actual IP here, which I can do, by the way, now from my UI, I can see indeed that I did a build, I deployed, and I released. And my deployment, the version is the same as the released version. And the release is running on this public IP, this load balancer IP, which was provisioned automatically by Kubernetes because I specified the type load balancer. If I click on that, I should also see my function app. This is, of course, the one which I, so to speak, open to the public. Right? Good. It's nice that you have this interface as well, so you can see indeed what builds did you do and so forth. Now, the fact that we have this waypoint entry point as well, it also gives me insight into the logs of my application. I can also exec into the application. Now, not from the UI yet. So that I have to do from the CLI. So if I do waypoint exec and I specify I'd like to run bash, I can basically go on my Azure Functions container and you can see it's an Azure Functions container because indeed you have this Azure Functions host there, but you also have some software which was introduced by Waypoint itself, the waypoint entry point, which enables us to do exec and to do logging and so forth from within this application. Let's exit from this. If I do waypoint logs, normally I should also find the logs there. As you can see, these are the Azure function logs. So if I would start using my function, the log would dynamically be shown. Well, let's just do that. And let's just do a call to API hello. And we specify the name, question mark, name equals Geert. When I'm doing so, indeed, I'm getting a response. And here you see, we are executing this function. This is something that we log ourselves to the screen and so forth. So I can track the logs from my local development system, from my live service, which is running in the cloud, in this case on AKS, on a Kubernetes cluster, right? Great, that's fine. And of course, when I'm finished with this, or I don't like to continue with it further, I can just use waypoint destroy. But before maybe I do that, let's do k get deploy. So there you see that there will be a deployment for, as you can see here, this WP test hello deployment that was created by the waypoint up command. And when I'm doing k get the pods, you see here that we have this this version here running. That's the one that we had. If I'm now doing waypoint destroy will of course undo all that. So waypoint destroy destroys the releases, destroys the deployments, and if we then go and look at the deployments, you'll see that deployment is gone. If we look at the pods, you'll see that the pod is gone as well, right? This is something that was that is done for you by running this waypoint destroy. Now, this is a relatively simple application. I want to just touch on something which is a little bit more complex, just a little bit more, not too complex. And that is, you can also have projects which have more than one app. So in this case, I have an app here which is called Dapper Demo. That one has two apps, Dapper Node, Dapper Python, right? And I just want to give you a hint about the HCL that you then need to write for that. I'm not going to run or do a waypoint up and so forth for these ones because the concept is the same, but I'm going to explain a couple of the different things you will see within that HCL file. So that one is in another folder. I'm going to clear this out. I'm going to go to, in this case, the Dapper folder. I'm going to open it with Visual Studio Code. This example is using Dapper, but that's not really important, although because Dapper requires us to do some annotations, we can also take a look at how we can add these annotations to the HCL. So briefly, what do we have here? So this is our project, but we have an application which is the Node app, which is, the code is in app.js. And then you have a Python app in a separate folder. The code is in app.py. So these are my two applications which are part of the same project. And then I have indeed my waypoint HCL file that will need to reflect that. Now, the same as before, we define a project, and now we define multiple apps. So we have this app Dapper Node, but we also have an app which is Dapper Python. The app Dapper Node is very similar to the app you've seen before, the Azure Function. The only difference is we have to tell waypoint, where's the path? Where is the app? What's the root of the app? Well, the path is Node, the Node folder over here. And instead of using Docker, we're using buildpacks in this case. I'm not going to show all the output of the build pack, takes a bit longer, but just know that this creates the Dockerfile, or let's say the Docker image for you. If you go to the Node folder, there is no Dockerfile here. Before, I had a Dockerfile and I could use that. Now I don't have it. And basically I'm saying I don't care about it. Let the system make it, build it for me. That means we use buildpacks. Now, of course, the buildpacks need to detect the language and need to know how to start your app. Yeah, for Node, that's simple. There's a package JSON there. It knows it's a Node app, right? And to start your app, the buildpack knows it from having a start script that specifies, hey, to run my app, do node app.js, right? That's all that's required for the buildpack to detect its node and to build an image properly. Yeah. By the way, when you use pack, you will indeed use the buildpack to build the image. You will also inject this extra waypoint software to do logging and to do the exec into the container. Now, just like before, whether we use Pack or Docker, it doesn't matter. When we have a build image, an image that has been built, we are going to push this to, in this case, Docker registry. As I said, other registries are supported. And then we deploy to Kubernetes just like you've seen before with the Azure function. There's no difference. The only thing is here that the service port is port 3000, the probe path is /. But because this is an application that requires annotations, as I said, it's a Dapper app. If you don't know what Dapper is, look on my channel, you'll find some videos. Yeah, we need to provide some Dapper annotations here. Luckily, Waypoint allows us to provide a list of annotations, and we do that in this format. So then when Waypoint is doing the actual deployment for you to Kubernetes, he sets these annotations properly. And yeah, the Dapper IO/enabled is true, means I will get a Dapper sidecar injected and so forth. Great, that's for the Node app. To actually deploy that app, for example, if you wanted to do Waypoint up, you would actually say Waypoint up-app and then provide the name of the app. You don't do Waypoint up and then all your apps will be deployed. You have to specify the app you want to bring up. Or you could do Waypoint build-app, Waypoint deploy-app. It depends a bit on how you want to work. So for this Node app, because the Node app exposes HTTP endpoints, it can also probe this one for liveness, and this works properly. The problem is here that my Python app is a little bit different. Yeah, the Python app, of course, the definition is the same. So app and then a name. The path is Python. That's all great. Building it, it's the same. I'm using a pack. But of course, here I need to know, how does Python work with buildpacks? Well, in this case, the buildpack requires that there's a requirements.txt, because he needs that to do installs with pip of these packages. So you need to have that. You also need, well, in this case, you need a proc file. The proc file determines what app should be run, what Python app do you want to run. That's in this case, the app.py, so web:/python app.py. That's what the Heroku buildpacks need to properly detect, hey, it's Python, so I know what I have to do to build the image. But for the rest, it's just the same. We just say use pack, and we let the Heroku buildpack build the image for us, which we subsequently then push again to a Docker registry. No difference there. But notice the deployment. The deployment is not with use Kubernetes. Because as far as I can see today, and of course, if I'm wrong here, please correct me, this one does require a liveness probe. Yeah, I don't have a liveness probe. I cannot do an HTTP liveness probe to my Python app because my Python app doesn't expose HTTP endpoints. Well, it doesn't really matter. If you see that for some reason you're not getting there with the default deployment backends which are supported, you can always use exec, because exec just uses executables, command lines you run from either your local machine or from a build agent in the cloud. So I'm saying use exec, and in this case I want to do kubectl apply -f, which sadly of course implies I will need to create some YAMLs to deploy to Kubernetes correctly. The problem of course is that I want to inject the image name of my Docker image in that template. So what we can do here is we can provide this placeholder here, the TPL placeholder, and then specify where is the template. The template is then set here. So template with the path to the template, which in my case is here in this folder python.yaml. And within the python.yaml template, we can use the typical Go template syntax to do stuff like I want the Docker image name to be injected. And there are other ones as well, like things like environment variables and so forth. More can be done than what I'm showing here. If you look into the template that I have, you see, for example, that I'm using also a namespace definition, and the name of the namespace, I'm using .workspace. Yeah, workspace is a concept from Waypoint, And by default, the default workspace equals default. So that means I'm going to create a namespace called default, which of course already exists, but I'm also going to deploy my app to the namespace in Kubernetes, which is default in this case. So it provides you, workspaces provide you with a way to also specify namespaces, for example, in Kubernetes, and then reuse that in, like, let's say, a template. Of course, the important part is, the container I'm going to deploy. I'm using this variable over here to get the name in there. And of course, because now I'm using the YAML files, the annotations and so forth, I'm doing normally. And in this case, I do not have a liveness probe defined. I could, of course, define non-HTTP liveness probes here. Didn't do that. But that's what I want right now, because I don't want this liveness probe on HTTP, because that's not supported by, in this case, by my Python app. So that means that if we would now run do waypoint up for Dapper Node and for Dapper Python, this would all work, but the Node one would use built-in Kubernetes deployment mechanism, and the Python one uses the exec method. If you think about it, with exec, you can basically do anything, right? So whatever you want to do, you can automate that with the exec functionality, and use templates and templating as well. Look at the documentation to see how that works in more detail. So if you look in the UI, you see indeed Dapper Demo has two applications. I have my Dapper Node, for instance, and I deployed those already earlier, and that worked properly. So I built with a pack. You can see that here, deployed by Kubernetes and then released by Kubernetes. But I did some deploys which are further than just the latest release. What I also have is my Dapper Python app, and in the Dapper Python app, what you will see is that the actual deployment and release was done with exec. So you can clearly see what is going on there, right? Great. So now you have seen this basic example with an Azure function. You have seen how that you need to provide some HCL, and you have seen an example as well where, let's say, the default Kubernetes deployment didn't cut it, and we're using exec to do the actual deployment, which is always possible. Now, of course, there's much more to be said, and I do recommend that you go to the tutorials, which will bring you over to learn.hashicorp.com, and there are all kinds of getting started guides to also introduce the other aspects. For example, myself, I'm going to certainly play around with something like Google Cloud, just to see how that works as well, and to deploy, for example, my Azure Function app container to Google Cloud, for instance, just because you can, right? So I hope this was a useful introduction to Waypoint. Probably might be some other videos about that later if I know some more about it, around versioning and stuff like that, when they start to shape up. So hope you liked it. See you another time. Bye bye.